Let's talk about the next problem in calculus. Over here, we have to find the area bounded by the curve y is equal to e raised to power minus x with the x-axis and the y-axis. So, first of all, let's have a look at how the graph of e raised to power minus x looks like. So, over here you can see the graph or the curve drawn in pink represents e raised to power minus x, and the area bounded by the curve, the x and the y-axis is clearly the area shaded in green. So, I am supposed to calculate this area, and I know the concept that I have to use here is integral calculus. Now, as a student, you may not be familiar with the graph of e raised to power minus x at this stage. In that situation, all you have to estimate is the initial and final limits of integration. So, first of all, let's look at the graph and see the limit values. So, over here you can see, if I have to calculate this area under this curve, I have to take the limits as 0 and the point of intersection of e raised to power minus x graph with the x-axis. But I can see over here that this graph never intersects x-axis, which means it will intersect x-axis at infinity. We can say it like that essentially, while we are saying that it will never intersect. So, I can say the limit of integration in this situation will simply be from 0 to infinity. Now, if I don't know the graph's value already and I have to find out the area bounded by this graph, x-axis and the y-axis, I have to use this idea. That first of all, I know the y-axis intersects the x-axis at only one point, which is 0, x equal to 0. So, my starting point has to be x equal to 0. Now, to find the upper limit, I have to basically solve the equation where this graph takes the value of 0, which means when this graph essentially intersects the x-axis, because the value that this graph takes is simply the value of y. So, when y is equal to 0, this graph will intersect the x-axis, and that will be the upper limit of integration. So, if I simply solve e raised to power minus x is equal to 0, I can already see from here that x has to be infinity, because then e raised to power minus infinity will give me the answer of 0. So, I can once again, without using the actual graph, determine that the lower limit will be 0 and the upper limit will be infinity. Now, once I have figured out the limits, I can start up with the calculation of the area. So, I know the concept of integral calculus tells me area under the curve of a function y is equal to fx can simply be given by integral from a to b fx dx, where a is the lower limit and b is the upper limit. Now, for our case, we have fx as e raised to power minus x, lower limit as 0 and upper limit as infinity. So, our integral turns into from 0 to infinity integral e raised to power minus x dx. Now, we don't know any direct formula that helps us integrate this, so we will carry out a small substitution. Now, over here what we will do is we will assume minus x to be a second variable t. Now, if I differentiate it on both sides, the value of dx will come out to be minus dt or vice versa. So, if I put these values back into the equation, what I obtain is e raised to power t, because I have put the value of minus x as t, into dt, because I have put the value of dx as minus of dt. So, my integral will transform into integral 0 to minus infinity minus e raised to power t dt. Now, here you would have seen a small change in the limits, because originally my limits were 0 to infinity and now my limits are 0 to minus infinity. We have to make a change always whenever we do a substitution, because over here we have x varying from 0 to infinity and our t is equal to minus x. So, our t has to vary from 0 to minus infinity, which is just the negative of our original limits. So, once you have understood all of this, we know the formula for the integral of e raised to power t with respect to dt, which will simply come out to be e raised to power t itself. And once we put the limits on it, the final answer we obtain is simply minus of 0 minus 1, which is 1. So, the area bounded by e raised to power minus x, x-axis and y-axis, the entire area shaded in green over here comes out to be 1. I hope it is very clear to you. Thank you.